Right, so we've got question 8 here of the November 2022 paper, paper 1. There's so many of these papers, right? Anyway, so let's see how this goes. Let's start by just getting into the question, then we'll see where we go to from there of specifics. So let me get my pen and everything ready over here. I think we're good to go. Oh, that blue is going to be lovely. Okay, so we've got a function. F of x equals these things here. X is greater than p over 4. So we only have a part of the function. We can picture what this function looks like if we want to. It is and isn't useful, I guess, in some ways. So I've been say that, and I can already see that you might have a sense of what the function looks like, because p can't be, x can't be p over 4, but it's fine because we're dealing with x greater than p over 4. And that's the only restriction. So it looks like our hyperbola, so we've got something with some asymptotes, and it either looks like that or it looks like this. Now, in each case, we can see the function increasing and decreasing. Okay, wait. Things are going way too quickly here. What's going on? Well, we've got a function. So can you imagine you had a function that looked like that? Well, this function is always increasing, which means that its derivative is always, it's always going to be positive, right? Increasing, positive. So we have that kind of idea, or perhaps we had the opposite idea, and let's see, I'm busy setting everything up here again, and it's quite exciting. Oh, look at that. I'm actually getting better here. Okay, so we could have a function that was doing that, in which case it's decreasing all the time, so its derivative would always be negative. Now, another function might be doing something like that, in which case it's increasing, it's stationary, it's decreasing, the derivative's changing all the time. Right? And it's useful just having all this background thought as we go along, because then we're tackling more than just this singular question. So the function is defined by that. Find the derivative, hence determine whether f is an increasing, decreasing function, or neither. Perhaps it's one of those. Okay, so with that in mind, which one's that? That's rubber. Look at that. Okay, this is quite cool. I didn't have this set up like this before. So let's have a look. So a lot of so's. If we can look algebraically, what's happening with this function, it will tell us what's happening with it. So we know that f of x is equal to 2 minus 3 4x minus p minus 1. Now wait, there's some trickery happening already, and that's because we haven't derived something in the denominator yet, but we've derived something in this form. So we can find the derivative fairly straightforward, because we can use our chain rule and work out what it is. Now you'll see in the chain rule, so again, always just maybe looking ahead, that this minus 1, this exponent, will change to negative 2 in the derivative. In other words, the denominator of this part here will be something squared. Now, something squared is always positive or 0, but because x is strictly greater than p over 4, and this is going to be the bracket 4x minus p, then 4x minus p, this squared is always going to be positive. So again, I'm sneakily not getting stuck into the algebra so much, but thinking ahead and looking at some of the concepts. So we know that if that's always positive, we just need to look at what's happening with this numerator over here and see maybe that numerator is always going to be negative or always going to be positive for the given x values. Well, I'll leave you to fill in the details, and we can look at those if you want to, because the memo has some of those details as well. Okay, well, let's see how that came out, and I'll see you in part B, where we'll look at a little bit more algebra, because it looks like some algebra will play a better role there. More role. I don't know what's happening. Anyway.